function. A constant function is a function that has a constant. A constant is a number without a variable. So a constant function would be like what y equals 4. Crazy. I know. Intense. So if we drew that graph, at y equals 4, like this dashed line points 4, you would have a completely horizontal line. This is the function y equals 4. So constant functions are just horizontal lines. Okay, let's talk about domain and range. Domain of this function. Okay, domain is the x and range is the y. If you forget, this is how I remember. Domain x, if I draw a line under it, no tails. Range y, if I draw a line under it, they both have tails. You're welcome. All the knowledge. All the things. So, domain is the x's. And when you teach it in grade 10, is there something more painful in life? I don't think so. I think I would rather actually get a pen, like a, I don't know, I would rather stub my toe, which I do really badly and it hurts a lot, than attempt to teach domain and range to grade 10 children. It is the hardest concept of all of grade 10 to understand. You hit grade 11 and you kind of get it a little bit, but you're still like, I hate it. So even actually, people more hate domain and range more than fractions most often, which is kind of crazy to think. I love both equally, just like my children. I love each of them equally as well. Same with domain and range and fractions. Both on the scale of love. Okay. If you think of domain as and range as what x values are not there and what y values are not there, it's sometimes easier than what is. Okay. So if I look at this graph. On this graph, could I find a coordinate when x equals 1? It would be here, right? Could I find a coordinate when x equals 2? X equals 2, not y. X equals 2? Yep. What about 3? Yep. What about 4? Yep. What about 0? What about negative 1? What about negative 2? What about negative 3? What about all the spots in between those numbers? All the x in between those numbers would also be like 1.1, 1.9, 1.5, right? Is there an x value I can't find? Is there arrows on the ends of this graph? Does it go on for life to the left and on to the right? Yeah. So can I find all the negative numbers? Can I find all the positive numbers? Does 0 exist? So are there any x values I can't put on this graph? No. If every x value exists, if there's not a way I can find you some trickery of an x, it would be x and out of the rails. Now, you have to write it in the way that I write it. You can't write it in a different way. You can't do different brackets. Because in mathematics, just like in English, certain things mean certain things, and you have to do them that way. Symbols in mathematics mean things. So the reason why your teacher told you had to do a squiggly bracket is because it means the set of. The set of. So can you do a round bracket? No, it means something totally different. Can you do a square bracket? No, it means something totally different. You have to do a squiggly bracket. Now, if your squiggly bracket looks like that, and you just did like 1, 2, 3 bubbles, cool. They're not like marking you on, that squiggly bracket isn't pointy enough. Like, that looks good, that's fine, okay? But if you do a square bracket and say, it's a squiggly, no, it's a square, it's not a squiggly bracket, okay? I don't know the actual form of what kind of bracket that is, but I call it squiggly. So the squiggly bracket, some people call it a curly bracket. I like squiggly. So it's the squiggly bracket, which is, and it means the set of, okay? Now, what variables do I have in here? Well, the domain would be x. So the set of x, if they had like a t or a whatever instead of an x, you'd have to put a t there. So what I'm saying is the set of values, the variable I'm using is x. We don't even have an x in here because it's a constant function, but if we did, we could say x to the 0. Remember we talked about that? Because x to the 0 is just 1. So it is variable x. The domain x, and then we do a straight up and down line. Because in mathematics, a straight up and down line means such that. And then we're going to follow, so this is what this means. It means the setup, we've talked about sets, right? We did a whole unit on it, of x values such that, so now I'm telling you the variable for domain is x, that's what this means. The variable domain is x, and now I have to tell you what the heck it can be. X is an element of the reals. Close your squiggly bracket. So everything is there for a reason, that's why you can't skip it. Right? X such that x an element of the reals. We good? Okay, range. Oh, some people are like, can I use interval notation we did in 20-1? No, interval notation is not allowed in 30-. So that's the round brackets. You go negative infinity, positive infinity, round brackets. Doesn't get taught in 20-2, but does get taught in 20-1. Can't do interval. It is out. Bummer, it is true. All right, range. What y values do not exist on this graph? All of them except what? 4. Is 4 the only y value that exists? Can I get y equals 0? No. What about y equals 3? What about 3.2? What about 4? What about 4? What about 5? What about infinity? So 4 is the only one that exists on this graph because it's a constant function at y equals 4. So let's talk about our range. So our range is going to be, squiggly bracket, y. Why did I put a y there? Because my equation's variable for y is y. If my equation's variable for y is f of x, I'd have to put an f of x there. If my equation's y is h of t, when you guys did height equations in grade 11, for like a ball being thrown or a rock being tossed off a cliff or whatever, it was h of t. You'd have to use h of t, whatever the y variable is. This one is y, so we get to use y. Such that y equals what? 4. That's it. Finito. Y equals 4. Boom. Can't be anything else. So that first variable tells you what the variable is. What is y's variable for this equation? And then after the such that, it's like, what can y be? Okay? Make sense? All right. Flip over. Linear functions. Y equals ax plus b. You were taught these in grade 10. So we're going to look at 2 of these. There you go. Boom. So your line just needs to be angled upwards, and it needs to have a positive y-intercept. It doesn't have to be exactly like mine. It needs to be angled upwards, positive slope, positive y-intercept. All right. In grade 10, we talked about these as y equals mx plus b. We don't use m's in grade 12 because we're going to use linears, quadratics, and cubics, and they're all going to have leading coefficients with an a. Okay? But this right here, this is a degree 1 function. Very important. Why is it a degree 1 function? Because the exponent, largest exponent, is a 1. Hence degree 1 function. Okay? Other thing to note is it's a linear function, because that's what they're called. It's a specific polynomial, which is a linear function. This is still a polynomial function, though. It's just specifically a linear polynomial function. Okay? All right. This is what we need to know. The leading coefficient of linear, quadratic, cubic, any of the 3 polynomials we're dealing with this unit. The leading coefficient tells you how the graph ends on the right. If it's positive, it ends up. If it's negative, it ends down. So if it's positive, it ends up. If it's negative, it ends down. Okay? The leading coefficient, just for actual definition terms in case you forget what it is, the leading coefficient is the number that leads the equation. So sometimes equations are not written in order. Sometimes you have 2 plus 3x squared minus 7x, and they're not written in order, correct? They're not in descending powers of x. Well, if they are written in descending powers of x, your leading coefficient is always the number that leads your equation. So it's the number in front of the largest exponent. So if you look at this one, x1 here, you see that? A is my leading coefficient. So this particular graph I made you guys draw. Didn't do a very good error there. That particular graph I made you draw is linear. It's a line, correct? It has an angle, it has a slope. If it's horizontal, it's a line, but it's a constant function, right? These ones have some sort of slope, okay? I told you that the leading coefficient tells you how it ends on the right. If it's positive, it ends up. If it's negative, it ends down. So let's look at how this one ends on the right. Is it ending up or down? Up. So I know I have a positive leading coefficient. And my coefficient is the letter A, correct? Did we agree on that? So how can I write out what A has to be in order for me to say it's positive? How would I write that out? A is what? 0. I've got the T on this. So A has to be greater than 0. That is a fancy way of saying A is positive, right? If A is greater than 0, A is positive. Yes? So down here, it wants the leading coefficient. I'm going to say A is greater than 0. Okay? Not dealing with any of the rest of the stuff right now. I'm going to draw you another graph over here. You sketch that graph now. Okay. Where does this graph end on the left? Up or down? I mean, and by left, I mean the other left, aka not left, aka right. How does this one end on the right? Down. So if it's down on right, what does that mean? Negative leading coefficient. Which means A is what? Smaller. Yeah, smaller, less than 0. Make sense? Clear? All right. One other thing, and then we're going to skip ahead for a little. Okay. B. Does anyone remember what this B stands for in linear equations? It was y equals mx plus b. Y-intercept? The y-intercept. Now, why is it the y-intercept? Did you memorize that? Why is it the y-intercept? When you hear y-intercept, if someone just like walked up to you and said, y-intercept, you would say, x equals 0, Mrs. Lepp. That's what you do. That's what you do. You don't know it, but that's what you do. Okay? Like if I'm like, hey, y-intercept, it's like x equals 0. I'm like, you got it, girl. And then I'm like, okay, y equals 0, and I'm going to be like, y-intercept, and she would say x equals 0, and then I'd be like, okay, I'm going to test you up here. I'm going to say x-intercept, and then you would say y equals 0, and I would say y-intercept, and you would say x equals 0. Because that's the only way you can land on those x-intercepts and y-intercepts is if the other one's 0, correct? Any x-intercept is on the y-axis and y is 0. Any y-intercept is on the x-axis and x is 0. So if we're just memorizing, does that scare me? Memorizing scares me because what if you forget something? Understanding doesn't scare me. So if we have the equation y equals ax plus b, we're just paying attention. We're putting down pencils. We're taking it all in because if we actually understand why it's the y-intercept, we won't mess it up. Okay? Now, why is b the y-intercept? Because when you hear y-intercept, you should scream at me x equals 0, so much so that I jump. You know? Like I did when Leighton put a snake under my desk. Like that. Okay? I almost didn't make it. It was not good. And I crawled under a desk instead of on top of the desk. But you wouldn't crawl under a desk if there was a snake. Because they crawl. Yeah, but I went under the desk. And then it was fake. It wasn't real. It was not okay. I survived, barely. All right. Touch and go for a few seconds there. So when I say y-intercept, you scream x equals 0. You scare me. It's immediate there. You got it in your head. Boom. You hear y-intercept. If you read y-intercept on a test, you think x equals 0. I always underline, highlight, write x equals 0. I immediately do that for my own little brain. Okay? If I read x-intercept, I underline, highlight, I put y equals 0 every single time. I do that for my brain. Okay? All right, so if we're talking about y-intercepts, and we remembered that b is the y-intercept, why is it the y-intercept? Well, if I'm looking for y-intercepts, I plug 0 in for x. Yes? Is that not true? Is that what we just said? Y-intercepts x equals 0? So if I go y equals a times 0 plus b, what's a times 0? She gone. So then I'm left with y equals b. So what was x? 0. Sorry, and then what was the y-intercept? Our y was b, which made this be our y-intercept. And that's why it is the y-intercept. Because when you fill x equals 0 in, you get b as the y value. Ta-da! Skies open, angels come down, singing. No? Good. All right. So we know that this is going to be really bothersome to me. I'm going to make this be a purple. This bad boy here is our y-intercept. And I can label it whatever. I could label this y equals smiley face x plus sad face. And you would tell me, oh, sad face is the y-intercept. Because the rest are going to go away when I fill a 0 in for x. Correct? This only works if the equation doesn't have brackets. If your equation has brackets, you can't tell me the back number. Now, I want you to side note. Put pencils down, because people will tell me this is the y-intercept and it's not. So I'll give someone this equation. Y equals 5x minus 6. And people will say, oh, 6 is the y-intercept. Nope, because why is it not? If I plug 0 in for x, I get 0 minus 6, I get 5 times negative 6, and oh boy, I get negative 30, which is absolutely not negative 6. Correct? We agree? So if you have brackets, you can't say the constant is the y-intercept. You would have to distribute through, you would get 5x minus 30, and then I could say, oh, there's no brackets. That's my y-intercept. Because I could plug 0 in for x, and the other part will go away. Okay? So the constant is the y-intercept, if and only if there's no brackets. So this is your y-intercept, and it is called the constant. And why is it called the constant? It's called the constant because it remains constant no matter what x value I give you, because it doesn't have an x on it. Okay, let's discuss constants. If I give you the equation y equals 7x squared minus 6x plus 5. Say I give you that. And I tell you x equals 2. Is this going to change? If x equals 2? Yeah. If x equals 3, is that term going to be different? If x equals 4, is that term different? If x equals 2, 3, 4, is that term different? If x equals 2, 3, 4, does that one change? No, it remains what? Constant. hence why it's called a constant. I actually don't know if that's why, but that's what I make up the definition. It's constant. If you plug in x's, they don't change. You know what I mean? Okay. Let's go back. So, the constant is the y-intercept. What can you tell me about this y-intercept? It's positive. You can't tell me it's like 7, 10, 5, 9, 2. You'd have to be like, what's the scale? What is this word? Right? You can't give me an actual number because I put no numbers on here. But you can tell me that the y-intercept is positive. Guys, am I allowed to short form on a test y-int? No, I'm not allowed to short form ever on a test. In your notes, can you short form? Sure, they're yours. I'm not marking them. So the y-intercept here is positive, correct? How do we determine that here? So what's the letter for y-intercept? What's the y-intercept letter? B. B has to be what? Greater than 0. Exactly. Because B is the y-intercept. B is the constant. Now what about this one? B is less than 0 because it must be opposite because Mrs. Lepp gave me 2 examples and they have to obviously be opposite. No, trick question. This is your y-intercept, and what is it? Your y-intercept, and it is positive. So it is greater than 0, and the y-intercept is still represented by the constant, which is b. So b is greater than 0. Does that make sense? So our leading coefficient, the letter in front of our largest variable, tells us how it ends on the right. We know that linear graphs, some people are like, but then I don't know how it ends on the left. Linear graphs are straight lines. So if it ends up on the right, it has to end down on the left, right? Like that's just the way it has to go. So leading coefficient tells you you're right, you're up on the right or down on the right, but then because it's linear or degree 1, it ends opposite on the left. So we're going to skip ahead a little bit. We're going to come back to this, don't worry. We're just going to try and solidify what we just learned down here. So you're ahead a couple pages. So flip ahead off to the next side. So you just flip over one page. Okay, we're at the bottom of the next page. Yep. So if you see here, A, B, C, and D are all what type of equations? Starts with an L. They're linear. Or degree 1, right? So we're all going to have straight lines here. Okay. This one here, A is still my what? A is still my what? Leading coefficient, and it tells me how I end on the right, correct? So this one has a leading coefficient, an LC. Can I write LC because it's my notes? Yes. Could I write LC on a test? So we have A is greater than 0. It ends up on the what? Up on right is what that means, correct? If your A, which is your leading coefficient, is less than 0, it means it ends. What is this one? What does that mean? A is less than 0, which is my leading coefficient. What does that mean? Down on right. Okay, cool. What does the B help me get? Y-intercept. So this one, B is greater than 0, which is my constant, right? So what is this telling me? B is greater than 0. What is it telling me? My y-intercept is what? And I can short form because it's my notes. What about this one? What is my y-intercept? It's positive. So I'm going to sketch the first one for you. And then you're going to do the other 3. I don't know what's going on. It's like checker colors all the time in my world. Okay, so we end up on the right in a positive y-intercept. Cool. I'm going to put the y-intercept here because I'm not a rebel. I can put it here, 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 anywhere that's above the x-axis. Do we agree? Now it needs to, the only other stipulation is it needs to end up on the right in a straight line. Correct? So I'm going to go like this. Watch me. Like that. Could I went like this? Could I go like this? Is it still ending up on the right? Yeah, any of those are good. Boom, just drew another one. I'm just so great at this. Oh, I could go super vertical. Still ending up on the right, still going through that y-intercept. Does the y-intercept have to be in that one spot? No. Do you need to draw 77 graphs on this one graph? No, that was me being overly excessive. I want one. Okay? So I want you to do B, C, and D. If it has a positive y-intercept, your y-intercept's above the x-axis. If it's a negative, your y-intercept's below. If A is greater than 0, it's up to the right. If A is less than 0, it's down to the right. Try them out. So, let's sketch this next one. So we have down on right and a positive y-intercept. So somewhere up here, and down on right. So your graph should be going something like this, with a y-intercept that's above the x-axis, correct? The angle at which that happens doesn't really matter. The next one, this is positive on right, and this is negative y-intercept. So we need a negative y-intercept. Boom. There, I just literally put my point. People are like, how do you pick it? I just took my pen and I said it has to be below y, and I tapped the board. That's literally my thought process in that y-intercept. Okay? Don't overthink it. And then I have to be up on the right. Cool. Boom. What was my thought process? I needed to be up on the right, and I didn't want to make it aggressively steep. But you could. It doesn't matter. You could make it flatter. You could make it up, right? Just needs to be up on the right. Now this one is down on the right, because it's a negative leading coefficient. And this is a negative y-intercept. And I'm short forming because these are my notes, and I'm allowed to short form a notes. Okay, I need negative y-intercept. There. I was just, perfect. And then it needs to be down on the right. That means down. Crazy. So I need to be a straight line and down. Did that cover the straight line and down prerogative? Okay, then we're going to flip back to where we went to. All right. Now we need to talk about number of x-intercepts. If I have a straight line, is it going to cross through the x-axis? Always. If I have an angled straight line. At some point it's crossing through that x-axis, correct? Angled straight line is going to cross through. If this is the x-axis, no matter how I turn that straight line, it's crossing through at some point. Even if I start up here, it'll cross through here. Or start up here, it'll cross through there, right? At some point it's going to cross through. Can it cross through more than once? Can it loop back if it's a straight line? Can it loop back? No, it's just going to carry out. So what are the number of x-intercepts possible for a linear function? The number of them, not what they are. How many possible x-intercepts can I have? One. Can I have more than one? No. Can I have less than one? No, that line's crossing through no matter what, correct? So the number of x-intercepts is 1. Domain and range, everyone's favorite. Here's my little line. I look at my little line here and I say, okay, what x values don't exist on that little line? What x values don't exist? I got a piece of paper. Can't touch the board with it, it'll start writing on it. Okay, let's start over here. Do the negative values exist? If I go, because x goes this way, correct? I'm going to go left. So if I put a piece of paper on here, can I find 0? Yeah, it's right there. Can I find negative 1, negative 2, negative 3, negative 4, negative 5, negative 6? Can I keep sliding the paper this way because there's an arrow? Okay, cool. Did I get all the negatives on there? Are all the negative x values there? Okay, what about the positive x values? I don't care that this graph is angled. I care that there's an x value that exists for every x value. What about this way? What about x equals 2? X equals 2? What about x equals 3? What about x equals 4? What about x equals 5? Do I care what the y values are, or do I care that I can find a point at those? Yeah. 1? What about 0? What about negative 1? What about negative 2 on the x? What about negative 3, negative 4, negative 5? Because this is negative 5, correct? This is negative 6. Can I find it? 1, 2, 3, 4, 0, 1, 2, 3, 4. Can I get all of them? Does every x exist on this graph? Yeah. Cool fun fact. All polynomials, every x exists. Best domains ever. So what am I going to write if every x exists? Squiggly bracket, because it means the set of x values. Why is it x values? Because the equation has an x in it, such that x is an element of the reals. This one is going to be the same, because every linear function is x such that x is an element of the reals, because all the x's exist on it. It's a straight line that goes on forever. Let's discuss range. Does y equals, range is vertical, correct? So does y equals 0 exist on this graph? Yeah, what about negative 1, negative 2, negative 3, negative 4, arrow keeps going, so all the negatives, cool. What about 0? Okay, now what about 1, 2, 3, 4, 5, 6, 7, and then it goes on for life up. Are there any y's that don't exist? No, so it's y's and element of the reals too, which is great about linears. They're both. You guys memorized it in grade 10, didn't know what. Do we use y or do we use a different variable? Look at my equation. Does my equation have a y in the y spot, or does it have h of t or f of x or g of x? It has a y, so I'm going to use y. If it had h of t, I would use h of t. Okay? So it's going to be y such that y is an element of the reals, because all of the y's exist. Okay? Grab a separate sheet of paper. Instead of giving you a homework question, I'm going to give you a few questions on the board that you can do right now and have no homework. You can do these wherever you want. Yeah, sure. Do them wherever you want. I'm not even looking at these after. I just want you to try them. All right. What is the domain and range of all of these? Yeah, what's the domain and range of all of these? X such that x is an element of the reals, and y such that y is an element of the reals, because they're linear. They're not a word problem. The only time the domain and range changes is if it's a word problem, because it couldn't have negative time or something. Okay? I want you to give me the leading coefficient of each of these. Did I ask for the sign or the actual leading coefficient? The sign or the actual leading coefficient? Does it say leading coefficient sign, or does it say leading coefficient? It says leading coefficient. So we'll do the first one together. What is the leading coefficient of A? 7. It's the number in front of the largest variable, correct? You quickly give me the other two. And by quickly, I mean it should be really quick. What's the leading coefficient of B? Negative 2. What about C? Negative 1 over 4. Those are your slopes, which could help you draw it. But really, we only care about the sign if we're talking about other things, correct? So the leading coefficient is 7, negative 2, negative 1/4. Not net positive, negative, negative. I didn't ask you for the sign, I asked you for what it was. Now what I want is, what does that tell me about this graph? What does this positive 7 tell me? Up on what? Up on what side? Right. You answer the next two. What does that leading coefficient tell you about the next two? What does the -2 tell me?
Down.
Because it's negative, it's down on right. What does that indirectly tell me about the left, guys? Because it's linear.
Up.
So if it's up on the right on the first one, what's it on the left?
Down.
Down. And if it's down on the right, what's it on the left?
Up.
Up. Because it's a linear line, it has to be opposite. Correct? What about this one? Negative leading coefficient. It means it's
Down.
down on the right. Okay, I want you to list me the constant of all three. What is it? Tell me what the number is for the constant. All right. What's the constant of this one? -4. It's true. Not 4. -4. We take sign with it, right? What about this one? +6. Of this one? -2. What does the constant give me? But why does it give me the y-intercept? Is x equals 0. And when I fill a 0 into this equation, I'm left with -4. When I fill a 0 into the second equation, I'm left with 6. When I fill a 0 into this one, I'm left with -2. And that is why the constant is the y-intercept, not because I just told you that. Okay? So, y-intercepts are not just a number, although you guys give that to me all the time. Y-intercept is an actual coordinate, correct? So this one is going to be -4, comma 0. Would you agree? You write out the other two. Should not be a long task. Oh, I didn't want that. All right, so this y-intercept is going to be at 6, 0. This one's going to be at 6, 0. Anyone calling me out on this? Why are we not calling me out on this? That ain't no y-intercept. That's freaking sadness is what that is. I don't know. Yeah, but why do you not speak it? 0, -4. Because when we hear y-intercept, we say what? We scream x equals 0. We scare me like a snake. Sneaky snake. Okay, 0, -4. 0 and 6. 0 and -2. Okay, how many x-intercepts do all three of these have? 1. Now, fun fact. You know, not necessarily fun fact. Fun fact. The degree of your function is the absolute maximum number of x-intercepts you can have. So, what are these functions all? Degree what? They're degree 1. Degree 1, degree 1, degree 1, degree 1. So at maximum they can have 1 x-intercept. We agree? Because they're odd functions, they end in opposite directions. So this is like a straight line that ends in an opposite direction. So it can't miss and have no x-intercept. Sam is done. Throwing his pencil at me. instead of I hate you. No, it is. But, all right. It's not curving back, correct? That isn't this drawing. That's a terrible drawing.